Hi, welcome to a2znowledge.com. So today we are going to discuss about the Hadoop framework overview. So big data has more than 10,000 plus solutions. So Hadoop is one such solution. So Hadoop, we today we're gonna see what are all the components that Hadoop has and the one-liner definition I'm gonna give, and a detailed explanation of each of the component will be I'll be uploading in my upcoming videos. And before getting into this video, I have one more video, a previous video, which is what is big data. So I strongly recommend you to watch that video before coming for this, since you are a beginner. If you are a beginner, okay, so you can have a look on that video and then you can come for this. I have given the playlist link in the description box where you can get all the big data related videos. Okay, so let's get into the topic. So before I start, what is Hadoop framework and what are all the components that Hadoop has? So I just wanted to give you an quick history of Hadoop. So in 2002, Google released a paper called GFS, which is Google File System. It's similar to the file system that we use in our Windows, right? NTFS. And then in Linux, we call it as EXT. In Mac, we call it as MacFS. So the file systems are generally used in our machine for by the operating system to read and write the data from and to the hard disk. But GFS is a distributed file system which will distribute the data before it writing to the hard disk. So the data will be get distributed across your nodes, your machines in the cluster. So why we need the data to be get distributed? So when the data, if only the data is get distributed, only then I can able to do the parallel processing, right? So all data I'm giving to a one particular person and I'm asking him to do, then it is not a parallel processing. So before I do parallel processing, my data has to be get distributed. So GFS is one such idea of distributing the data like a file system, means in the file system. So this was released by Google in 2002. In 2004, Google released another paper called Google MapReduce. This is for processing, or I can say ETL. So the processing for the data that which you have stored in GFS, and you have already distributed it by GFS. So in 2005, mid of 2005-6, the Hadoop has been released. The Hadoop used these two, means the developer of Hadoop, the father of Hadoop, duck cutting. So he used GFS and GMR as a base paper, and in Hadoop we call this GFS as HDFS, Hadoop Distributed File System, and in MapReduce we means in GMR has been changed as just MapReduce. So Hadoop has only these two projects. Even now, if you download Hadoop from Apache website and you install it on your machine, so you will be seeing only these two modules, HDFS and MapReduce. But you may get a question now, but when I search in internet, Hadoop, when I see Hadoop framework diagram, I can see like a lot of boxes in the diagram like hive, sqoop, Uzi, flume, HBase, so many boxes are there. Yeah, that's true, but Hadoop has only these two, HDFS and MapReduce. The remaining all other projects has been developed by different companies and different individuals and different group of community members, and they have contributed it to Hadoop. Okay, so even you and me can develop something and we can contribute to Hadoop. Okay, so today we are going to see all the components which is very familiar on top of Hadoop framework. Okay, let's see the complete framework. So one more thing I just wanted to tell you here. When you search for Hadoop framework image in Google image search, you will be getting a lot of images, and in each of the image you will be seeing some boxes extra, plus or minus or plus or minus 2 it will be there. But if you take Hadoop framework, we have like 8 to 9 solid components which will not change, and that is kind of a mandatory skill sets for Hadoop developers to know. The remaining all other boxes, it's like optional. Okay, so as I told you, anyone can develop and they can contribute to Hadoop, so they are optional. So I will show you the concrete projects which is very important, which was developed on top of, which is developed for Hadoop and which got integrated on top of Hadoop. So we'll see such ecosystem, Hadoop ecosystem, or we can call it as framework today. So people used to call it as Hadoop ecosystem or Hadoop framework. So we have two projects. One is HDFS and one is MapReduce. So when you install Hadoop, you will be getting only these two. So there is a difference between Hadoop and Hadoop framework, but that doesn't makes a bigger sound. But but still there is a difference. When you say Hadoop, only HDFS and MapReduce. But when you say Hadoop framework, so the components other than HDFS and MapReduce, which was developed by different people and contributed to Hadoop framework, Hadoop, right? So on the whole, we call it as a Hadoop framework. So the very first thing I wanted to establish here is, so HDFS is to distribute the data. It's like in Linux, you have Linux commands, right? So similar to that in HDFS, we have HDFS shell commands. So you can use that to interact with HDFS file system. And MapReduce is a framework which will process your data in parallel, and you need to do it via Java as a primary language, and we have secondary languages supports. It's MapReduce supports other than Java as well, like Python, C, C++ as well. But still, Java is highly preferable in MapReduce with respect to the performance wise. So here, the very first contribution for Hadoop which entered into market is Hive. So Hive is a component which is most widely used project. So like any Hadoop project you go and see, you will be seeing Hive there. Okay, Hive is most widely used in any Hadoop big data project. So Hive was invented by Facebook. The main reason is, as I told you, MapReduce, you have to interact with the Java. So what Facebook said, I'm not, my employees or my particular developers are not a big fan of Java. So I need the performance of MapReduce, but I don't want the way of interaction, the Java. I need SQL support for MapReduce. So Facebook invented Hive, so in which you will interact with SQL. In backend, it will be Java. Okay, so that means it's like a vehicle, and vehicle has an engine. So I know how to drive my vehicle, but I'm not sure about what the engine is all about. So similar to that. So you can speak in SQL with Hive, and internally Hive will write a Java part for you, so that you will still enjoy the performance of MapReduce, but you are doing it via SQL or SQL. So Hive is most widely used component in big data and even in Hadoop as well. Fine. So the next component was contributed and invented by Yahoo, called Pig, which was invented by Yahoo. And the programming, okay, so the language which we use on this Pig is called Pig Latin. It's a scripting language. Okay, it's not a programming language, it's a scripting language. So Pig Latin was used internally by Yahoo. The problem, the use case of Pig is why they have, how and what made them to invent this Pig, I will tell you. So similar problem for Facebook, right? So Facebook, like Yahoo said, I need the performance of MapReduce, but I don't want to write it in Java, and I don't want to write it in SQL as well or SQL. I I have my own scripting language within my org, and that is Piglatin. I need the Piglatin scripts should run on top of Hadoop. So they have invented Pig. So you can do all the data transformations in Pig via Piglatin. So internally it runs on top of MapReduce engine, and it will convert Java. So Pig will do that for you. So here Hive and Pig is kind of doing the same thing. So the use case wise, you can achieve whatever you are doing with Hive. Mostly you can do with Pig also, but familiarity wise, we are familiar with SQL, and that's the reason like Hive has more people are preferring Hive than Pig. But you can solve all type of problems in both Hive and Pig as well. But the familiarity wise, Hive is used widely used compared to Pig. Fine. So the next component is called sqoop. So sqoop was invented by group of community members. They've just joined a group in Apache, and then they have contributed their effort to invent this sqoop. So I cannot give you one company name or one single developer name here. It's a group of community members. A member could be a company or an individual, but it's a group of people. So who invented sqoop? So what sqoop is doing actually? Uh, See, you will be having some use cases to bring the data from RDBMS to Hadoop, right? So here, um, uh, I have to write a MapReduce program to do that. I want to migrate my data from RDBMS. I have to bring the data to my Hadoop, and then I have to do a process. So to bring the data itself, you have to write a code in MapReduce. So to avoid that scenario, means to, instead of writing a code to do that, so they have invented something called sqoop. So in the sqoop, what you will be doing is, it's like a commands. So there is no programming language in sqoop. It's called sqoop commands, it's like import and export. You will be giving all your database details, username, password, and the table name, URL, those stuff, your database URL. That's it. So sqoop will automatically go to your it reaches to your RDBMS. It will bring the data and it will store the data in Hadoop. And again, you want to migrate something from Hadoop back to RDBMS, right? So you can do that as well, export. So you can use sqoop to import the data from RDBMS to Hadoop, export the data from Hadoop to RDBMS. So that's what sqoop is doing. So sqoop is used for data pipeline. So it is used for data pipeline. So sqoop is very easy to learn. So there is no prerequisite required for you to learn sqoop actually. So sqoop internally, any sqoop commands that you run internally, it will be in Java. Okay, so sqoop will get the data from RDBMS to Hadoop and Hadoop to RDBMS. So sqoop is not for to read data from a file or a folder or from web server. So sqoop is only for RDBMS to Hadoop, Hadoop to RDBMS. RDBMS can be anything, Oracle, MySQL, DB, to any RDBMS is fine. You can able to connect. And the next component is Oozie, which was again invented by Yahoo. So Oozie is it's like an XML file. It will be like a filling the blanks. So Oozie is a scheduler. Okay, so it's if people are very new to the term scheduler, I will tell you. So you have to automate your work. Imagine I have done something in Hive. I want to run this particular Hive query every day at 2 p.m. Okay, so that means I cannot do that manually. Daily as a developer, I cannot put an alarm and then go back, means go to the system at 2 p.m. and then trigger the script. So I can do that in a manual way, right? So it has to be automated. So, and that is where in real time people will use some sort of schedulers to do that. So in Hadoop itself, we have a scheduler called Oozie. So we can use that to schedule all the Hadoop jobs, Hadoop and big data related jobs. And one more thing, it's out of the box, but I just wanted to tell you here. See, if someone says that there is means I'm working on Hadoop project and you're asking me the tech stack, what are all the tech stack that you are using? I'll be saying like I am using Hive, I am using HDFS, and I'm using MySQL. So MySQL is not part of big data, but still, uh, our expectation should not be like if someone said there is a Hadoop project, and we should not think the entire components what they are using will be a big data component. It will not be like that. Okay. So why I am telling you this now, the scheduler, especially the Woozy. So most out of 10 big data projects, only like 7 to 8 companies will use, sorry, only 2 out of 10 projects will use Woozy as a scheduler to do, but the remaining 8 projects or 8 different companies will use different schedulers, which is outside the box of big data. Like there is some schedulers like Control M, Autosys, Active Batch. So people will use such schedulers also to schedule your big data jobs. It's not mandatory that I have to use only Woozy because Woozy is part of big data and I'm also working on big data. It's not like that. This is not only for Woozy, I'm saying, even for the remaining things. Okay. Even you can consider Sqoop. So sqoop is something to bring the data from RDBMS to Hadoop, Hadoop to RDBMS. But imagine that there is some other tool which the company is using to do this. Yeah, fine, that's fine, absolutely fine. That is based on their design, right? So instead of sqoop, there is another product which is not a big data product, but it will bring the data from RDBMS and load it to my Hadoop. That's fine, but that's part of the design. It's not like sqoop only should do because it's a big data component. I'm working on big data project, so it will not be like that. So I just wanted to create a mindset for you. That's why I'm just explaining this. Okay, back to the topic. So it's like an XML file. So when your Oozie runs in background, it will be Java again. So MapReduce is an engine which is like used by all these components. Okay, so when you kill this particular MapReduce process, so these 4 components will not work. So we call these 4 components as abstraction of MapReduce. This is an interview question. So in interview, if someone asks you list all the abstraction of MapReduce, then you have to say Hive, Pig, Sqoop, and Woozy. So we have few more components in Hadoop framework, but they are not abstraction of MapReduce. Okay, only these 4 components are called abstractions of MapReduce. Okay, the next component. So the next component name is HBase. Hadoop database is called HBase. So this product was developed by Facebook again, and HBase, in HBase the query language we use called HBase shell commands. It's completely different. It's not like your SQL, and HBase is only works on top of Hadoop. We do have a lot of other databases. It's not mandatory. Hadoop needs to be get installed for other databases in big data, but for HBase it's mandatory. And if you see all the databases in big data, we call it as NoSQL databases. Okay, and modern database. Okay, modern database. Any database that you see in big data, we call it as a NoSQL database. So I also explained you what is NoSQL in Introduction to NoSQL. I have given a video. I have shared that also in the description box, the playlist link. You can have a look, but that is not mandatory at this point of time. Okay, fine. So HBase is again invented by Facebook. As I told you, this is a database for Hadoop and NoSQL. And Hive is a query engine. So people used to confuse with HBase and Hive. So Hive is a query engine. Since we are using SQL, don't think Hive is a DB. But in real time, people used to call it as a DB, but that's fine. You can go with the flow. But actually, the truth is, Hive is not a DB. It's a query engine. Okay. Alternate for MapReduce, Java. Sorry, not MapReduce. That's very important. People used to say Hive is alternate for MapReduce. No, Hive is alternate for Java. Still, Hive is also using MapReduce. That's an important point. Luckily, I got this in mind now. Okay, so Hive is a query engine and HBase is a database. So the next component, Mahout. So Mahout is a data science component for Hadoop. So you can do all ML, artificial intelligence kind of data science stuff in Mahout framework. Less used in big data environment. And then Flume. So, like sqoop, Flume also a data pipeline component, but sqoop can like Flume will retrieve the data in real time. Flume can connect with any like Flume can connect. So we call Flume as MQ, messaging queue. So Flume can connect with RDBMS also, files, folders, web servers, application servers. You can connect with Twitter to get the tweets and Facebook to capture the events. So you can do that. So Flume is as a messaging queue. So sqoop is only RDBMS, but Flume is not like that. And one more difference between sqoop and Flume is, so Flume is like it will only retrieve the data to Hadoop, but from Hadoop back to some other sources or targets is not possible. Only incoming. Okay, so similar to Flume, there is some tools like Kafka, Scribe, or some familiar MQs are there, but Flume comes under messaging queue. So these nine boxes, like 1, 2, 3, 4, 5, 6, 7, 8, 9. So these nine boxes is what, as a solid, we call it as a Hadoop framework. So you, as I already told you, you will be seeing few more boxes. If you go for Google and search for Hadoop framework diagram, you will be seeing different boxes got added with this. But these nine are solid, and like as a Hadoop developer, I should know these nine boxes. Okay. So two things about the Hadoop framework. The first one is not only Hadoop framework, any framework in big data. Yeah, even we have Spark framework and we have Storm framework. Any framework you take in big data, we call it as loosely coupled framework. What is loosely coupled? So there is two type of framework: tightly coupled framework and loosely coupled framework. If you take, this is a Hadoop framework, right? So in my project, I'm removing Woozy, and that means your Hadoop won't work. No, it will work. Even if you remove Woozy, your Hadoop and other boxes, other projects will still work. That is called a loosely coupled framework. Imagine in my project, I'm removing this Woozy component. I'm uninstalling this Woozy component, and that because of that, my Hadoop is not working. That means tightly coupled framework. So you might have heard about the .NET framework, C# .NET framework in Microsoft. So it's called tightly coupled. You cannot remove any of the components from the .NET framework. Then the entire .NET framework won't work. So Hadoop and any other frameworks, you take any frameworks in big data, they are loosely coupled. Anything that you want, you can remove, and then you can like plug in, plug off. So it's not like if I remove one component, the entire system will go down. No, it's not like that. Okay, and it's not mandatory that a Hadoop project should have all these component in their working environment. Not required. Okay, and the next thing is integration. How about integration? So what do you mean by integration? So okay, so I want to connect my Hadoop with any other big data technology. Okay, that is Spark. You might have heard at least a Spark. People will use Hadoop, Spark, these two terms in big data, right? So Spark is another technology, and people will connect Hadoop with Spark. So I will tell you all the use cases in the upcoming videos. So there is a scenario to connect. So the question is, can I connect Hadoop with any other big data frameworks like Spark or Kafka or Storm or any other big data framework. Yes, it's possible. 100% it's possible to integrate with any other big data framework. Okay. Next point. How about integrating Hadoop with non-big data technology? For example, RDBMS, MySQL, Oracle are not big data technology, but still you can able to connect. Yeah, now you know the answer. Sqoop is used to connect with RDBMS. So the question is, Hadoop can be connected with any non-big data component. So that I can tell you like 90 to 95 percentage you can do that, because currently all the projects are in migrations. Like they are migrating it from RDBMS, they are migrating it from ETL logics, they are migrating like Informatica databases like Teradata, ETL tool like Ab initio, and even you have some testing part also available here. And we have even mainframes. Yeah, mainframes is again, you can migrate data from mainframe. So 90 to 95 percentage I can say yes, Hadoop can be connected with non-big data technologies. So specific to the question only I can able to answer. So if you say some new technology and if I'm not aware of it, I have to research. Okay, so that's how solution architect will answer. Any others, I'm not a solution architect, but I'm just saying solution architects in big data environment used to say like that. But if you ask me the question, Hadoop can be connected with any other big data environment, yes, I can say 100% yes, it can be connected. Okay, so these two things is very important. It's common for all big data frameworks, the loosely coupled and the integration part. And now the final step. So we can categorize this into layers of data layers. So if you take storage, like HDFS is one storage, HBase is one, and then these two act as a storage part in Hadoop. And then processing, MapReduce, Hive, and Pig is for processing the data. Sqoop and Flume is acting as a data pipeline to bring the data from outside to inside, and again from Hadoop to outside. And Woozy is a scheduler, and then Mahout is for data science. So it covers like more than 4+ data layers, right? So and one, as I already told you, it's not mandatory to use all the component in your project. If you take one of my very old project, I have only Hive, MapReduce, HDFS. That's it. That's a big data project. So it also happens in that way. Okay, so we have discussed all these points like Hadoop framework and one-liner description of everything we discussed, and then like we discussed about the loosely coupled and the integration part of Hadoop. So this is wide enough for you to get into the next level of Hadoop framework. So similar to Hadoop, I have given a video for Spark framework as well, and you can go to my playlist and check. If the video is not there, I will be uploading it soon. Yeah, so thanks for watching A2Z Knowledge.com. If you really like this video, please do subscribe my channel, forward this to your friends and colleagues, and please share this in your LinkedIn. And we do a lot of tech videos in two languages, English and Tamil. Not only big data, we do have other tech videos in my channel. Just go and have a look. Thanks for watching A2Z Knowledge.com. I have given my LinkedIn and Instagram URL in the description box. Like please do follow me, and if you want to contact, you can contact via that. So thanks for watching.